Humanity has come a long way. It was only 1919 when we flew over the ocean for the first time. Now, a bit over a century later, we have flying vehicles exploring other worlds and probes traveling across interstellar space. Not an easy feat. But despite our achievements, many believe that some scientific leaps in our history had an unlikely boost from technologies alien to our kind as a collaboration, under which the most transcendent discovery of all times remains concealed. Whatever the truth may be, interest for understanding how special we really are within the universe has never been greater. This renovated interest is not disconnected from the US Intelligence Authorization Act of 2021, approved by the Trump administration, which mandates the Director of National Intelligence together with the DoD to compile an unclassified report on unidentified aerial phenomena, or UAPs, UFOs, new trendy nickname, expected to be released this June. There is a lot of skepticism gravitating this report, which could very well represent an inflection point in contemporary history. The quest for life beyond Earth is certainly not new. This year marks the 60th anniversary of the first serious search endeavor of this nature. Rockstar scientists like Frank Drake and Carl Sagan pioneered SETI, search for extraterrestrial intelligence, and developed state-of-the-art strategizing to this enterprise. Truth to be told, we are pretty much in the same place more than half a century later. We have come to know, however, that most stars have planets, and that many of those planets could orbit around the habitable zone. As of now, we have identified at least 4,000 exoplanets orbiting their stars, and there are thousands more waiting for confirmation. Soon, Earth might not seem so special after all. With this revamped interest for alien civilizations, and in the wake of the new milestone approaching, let's explore some potential outcomes through the lens of complex systems, which proves particularly useful at the borderline of our knowledge. In this region where not only data is often missing and statistics doesn't always apply, the sheer visibility of the underlying processes is as challenging as the very logic behind them. Armed with this framework, let's review what an eventual disclosure of the much-expected UAP report could teach us about the universe and about ourselves. The conjecture: complex systems, or complexity, arises from the basic structure of space-time. It is embedded in physics and prevalent in chemistry, but probably reaches its summit in biology with the emergence of life, particularly intelligent life. Under the premise that life is a complex system and that reproduction and evolution are inherent features to it, we can safely assume that life and its complexities are both driven and constrained by the laws of physics. Let us also assume that laws of physics apply throughout the observable universe as well. Now, let's suppose that the declassified National Intelligence Report on UAPs directly or indirectly confirms the existence of alien intelligent life. This would unquestionably represent the most important discovery of all times, but ironically, it might also come as no big surprise. I will argue that there are at least 3 reasons why this can be absolutely expected, the last of them being the evidence already acknowledged by the US Navy. So, let's now turn to one of the most unique complexity signatures: fractality. Fractality is a very special property of some complex systems, in which the morphology of the system repeats itself at greater and/or smaller scale. Rivers, broccoli, snowflakes are all examples of natural fractal systems that, when seen at a smaller scale, display the same morphology as in larger scale. This is quite relevant because, from the statistical perspective, we cannot draw any conclusions with a sample of just one observation of life in the universe. This is one of the obstacles preventing us from solving the famous Drake's equation, although is more likely that emergence of life would be additive instead of multiplicative as the equation. There are approximately 8.7 million of different species on Earth. Should this number seem large, note that 99% of all species have already extinguished along the course of Earth's 5 mass extinctions, the latest of which annihilated the dinosaurs, Cretaceous-Paleogene. This means that even though we only have one observation of an inhabited planet, this observation has actually recurred in at least 5 occasions, and most notably under very different geological conditions, that is, different planetary conditions. From a fractal perspective, we could say that evolution of life exhibits a sort of biodiversity fractality or recurrence, which may invalidate the one observation scenario. Contrary to the classic standpoint, life seems to emerge indefinitely and persistently wherever there are broad conditions for it, possibly unrestricted to time nor unique geological setups. Second, assuming, as we have, that life as a complex system has the tendency to reproduce and evolve, diversify, an epidemiological approach describing epidemic states would equate to 1 if mankind would be the only intelligent civilization to emerge in the cosmos, the one observation case. This is mathematically not different from Drake's equation, which factors in different parameters that allegedly modulate the detectability of intelligent life throughout the universe. Under either framework, whichever are the ultimate factors fostering intelligent life around a given star, we can assume they will not remain static in time, just as conditions of stellar systems are neither static. The scenario in which Earth is, has been, or will be the only inhabited planet in the history of the universe assumes that the myriad of factors that must converge to nurture intelligent life vary in such a precise way that they cancel each other's variation out to maintain the result of the equation exactly equal to 1 along the history of time. In order to gain some perspective on the unlikeliness of the one observation case, let us think for a second how there are 7.7 billion people in the world, each with approximately 11 billion neurons. This adds to 8.5 x 10 to the power of 19 human neurons in the planet, since there are around 1 x 10 to the power of 24 stars in the universe, and it is likely that each one of them has at least one planet in its orbit. Expecting that the sum of all potential instances of intelligent life emergence equals to 1 across eons would possibly be 100,000 times more difficult than expecting all human beings in the planet to hold exactly the same thought throughout their entire lives. It is orders of magnitude likelier to expect numerous civilizations across the universe, rather than just the one observation scenario. Many scientists and research papers applying different approaches arrive at this very conclusion. The evidence. For decades, UFO researchers have collected mounting evidence from real sightings. But in December 2017 and March 2018, something changed. A group of people assembled by Blink-182's Tom DeLonge and former US Intelligence Officer Luis Elizondo released 3 videos where aerial vehicles can be seen maneuvering as no human-made technology can. On this occasion, the U.S. Navy declared the legitimacy of the videos, making it the first time ever the U.S. government acknowledged the UAP/UFO phenomenon. From the videos, it doesn't take too much analysis to conclude that these objects are able to manage gravitational fields in a way in which we do not yet understand. Or so we think. Interestingly enough, Salvatore Cesar Pais, a U.S. Navy researcher, applied for patent US 101445532B2 for his craft using an inertial mass reduction device. On the paper, Cesar Pais states that a rotating device, such as a rotating disc, could generate an electromagnetic field with certain vibrational characteristics that would enable a vacuum-like force to offset the inertial mass of the craft. In absence of exotic space-time structures like Einstein-Rosen bridges wormholes, the need to find ways to overcome the gravitational relativistic constraints becomes compelling if we are ever to cross interstellar distances within the human lifespan. If we cannot find ways to isolate vessels from the energy-mass constraint, it would take more than 100,000 years just to reach the other end of our own galaxy, let alone galaxies far beyond. Distances in the cosmos are indeed insurmountably large, yet our visitors might not come from afar. This could be both fascinating and worrisome. Consequences. For all of us who are not George H.W. Bush Majestic 12 members nor researchers from the U.S. Navy, we might have a hard time deciphering much more about UAPs than what is shown in the videos. Fortunately, as Luis Elizondo puts it himself, disclosure is not an event, it is a process, and the process has begun. A factual source of concern is the strategy governments will ultimately adopt after disclosure. The old urban legend depicts a decades-long peaceful military and experimental collaboration. The new narrative highlights a potential threat UFOs/UAPs might pose to the security of military powers, chiefly that of the US. If such collaboration did exist, shouldn't it have incorporated the greatest minds, scientists, humanists, and religious leaders of the world? Shouldn't a multilateral organization like the United Nations have assumed the leadership on behalf of all mankind? If, on the other hand, these vehicles were indeed a threat and have been so for years, secluded from presidents and Congress, wouldn't that qualify as a major security flaw in the U.S. intelligence and military apparatus? The two main readings coalesce into either a major multilateralism fiasco or a catastrophic defense failure. Be that as it may, we can expect U.S. military industry to exert all its power to keep capturing the biggest part of $1 trillion one way or another, with peace and global cooperation directly threatening their status quo. The late Stephen Hawking and the popular Michio Kaku, among others, have also pointed out that aliens might not be necessarily friendly but rather hostile. This is certainly a possibility, and we don't have much data from where to draw any conclusion. Nevertheless, an unlikely source of complex systems analysis can give us a hint. In Anna Karenina, Tolstoy writes, "All happy families resemble one another, but each unhappy family is unhappy in its own way." The Russian writer speaks about the trade-off between complexity and entropy. The higher the level of happiness, support, satisfaction, collaboration, etc., the higher the level of complexity. Statistically, there are much fewer arrangements that allow complexity to emerge as compared to non-complex configurations. Intuitively, unhappy families deal with less collaboration, higher friction, larger disorder, etc., leading to higher entropy. Similarly, there are many more alternatives in which molecules, structures, individuals can be disordered, vis-a-vis ways in which they can hold productive and meaningful interactions, leading to possible emergence of complexity. This applies to molecules, human beings, and countries all the same. It is much easier to be a poor country with a lousy democratic system than a highly developed nation that champions human rights and promotes renewable energies. From the above, a qualitative corollary is that if there are multiple civilizations in more advanced technological stages than ours, they will be more complex, and the more complex they are, the more they should converge. That said, we are left with two options. 1, the more advanced they become, the more hostile they grow, or 2, the more advanced, the more civilized. If our own history can be used as an example, the latter statement should hold, as progress is a quality that is unlikely to be attained in absence of cooperation, not to say absence of peace. On the quantitative side, one could argue that the single most important piece of information we could take out from the grand disclosure would be where they come from. And no, that is not a tourism concern. If they come from another galaxy, in particular one far away, we could swiftly estimate the intelligent life emergence likelihood, which, whilst not unique, would still remain quite rare. This would reduce the probability of statistical outliers if, on the opposite side, they do come from a very nearby galaxy, even our own Milky Way or however they call it, then intelligent life and civilizations could be counted by the thousands or even millions across the universe. In such scenario, it is plausible that one or several civilizations may have attained high technological progress despite being hostile to other civilizations, statistical outliers. In fact, one could argue that mankind is not unmistakably friendly. Finally, examples from our own civilization suggest a positive relationship between hostility and isolation, but even if that relation does not hold universally, statistically, we should still have more fellows than foes around the neighborhood. Our generation is in for a treat. To be the first humans to ultimately apprise our true place in the cosmos cannot be benchmarked against any other event in history. The potential advantages the grand disclosure might bring could empower us to overcome the most alarming challenges of our planet, from sustainability to human rights to poverty. More significantly, it will grant us a comprehensive perspective of our own selves, enabling us to elevate humanity to a truly cooperative and constructive civilization that values gender, racial, and biological diversity, preserving and collaborating among species, foreign and domestic. Not an easy feat. Indeed.
If you enjoy this video and want to see more like it, please consider subscribing to us and hitting the like button. Feel free to write a comment below and suggest which theory you want to see next. If you'd like to further support this channel, please consider joining. Our membership link will be found in the description box below. We appreciate your support, and as always, thanks for watching.